morning student. Good morning students. Then today we discuss about nitric acid. So that nitric acid formula is HNO3. How to prepare that nitric acid? What is the chemical properties of nitric acid? Now today we discuss about that nitric acid, and this nitric acid which can be prepared from two process, that is one Ostwald process and Birkeland-Idje process. Simply this nitric acid which can be prepared from Ostwald process, which can be prepared from Ostwald process. Ostwald process. So now here that Ostwald process diagram is there. What is the diagram? Now in this one, so this is the diagram. So here first ammonia mixed with air in the presence of, this is platinum gauge, these are called catalytic chamber. So in this one ammonia mixed with air in the presence of platinum gauge to get what happen at certain temperature, to get nitrogen monoxide is formed. Nitrogen monoxide is formed. This nitrogen monoxide in the presence of boiling. Here chiller means this is boiling. That nitrogen monoxide that react to oxygen. Boiling means oxygen. To get nitrogen dioxide is formed. Nitrogen dioxide. So this nitrogen dioxide is formed in oxidizing chamber. Nitrogen dioxide is formed in oxidizing chamber. This nitrogen dioxide then which is cool and spray with water. To get what happen? Nitric acid is formed. To get nitric acid. That nitric acid contain 61% HNO3. Nitric acid contain 61% HNO3. So in this diagram, first what happen here? 4:5 ratio. 4:5 ratio. 4 moles of ammonia that react to 5 moles of oxygen in the presence of platinum gauge. To get what happen? 4NO plus 6H2O is formed. 6H2O. So that means, so in this one 4:5 ratio, 4:5 ratio of ammonia. This one ammonia mixed with air in the presence of platinum gauge. In the presence of catalytic chamber to get nitrogen monoxide is formed. To get nitrogen monoxide. And one more equation here, how to prepare this nitrogen monoxide? NaNO3 which react to sulfuric acid. NaNO3 sodium nitrate. NaNO3 sodium nitrate that react with sulfuric acid. To get what happen? NaHSO4. So NaHSO4 plus and to get HNO3 is formed. To get HNO3. So NaNO3 that react to H2SO4 to get nitric acid, which formula is HNO3. Now this nitric acid which can be prepared from Ostwald process. This is Ostwald process. 4:5 ratio. Ostwald 4:5 ratio. Ammonia mixed with oxygen in the presence of platinum gauge to get what happen? Nitrogen monoxide is formed. To get nitrogen monoxide. So to get nitrogen monoxide plus water. So this nitrogen monoxide is formed in catalytic chamber. This nitrogen monoxide is formed in catalytic chamber means Here ammonia mixed with air in the presence of platinum gas to get what happen, nitrogen monoxide is formed. Now what is that next one? This nitrogen monoxide. That nitrogen monoxide is boiled. This nitrogen monoxide is boiled with oxygen. Nitrogen monoxide is boiling to get what happen, nitrogen dioxide is formed, to get nitrogen dioxide. So this nitrogen dioxide, that means here what is, nitrogen monoxide is formed in the presence of boiling. This is in the presence of boiling at 150 degree centigrade. To get here, nitrogen dioxide is formed in this tower, nitrogen dioxide. So this tower are called oxidizing chamber. This tower are called oxidizing chamber. In this, nitrogen dioxide is formed in oxidizing chamber. Oxidation chamber. Here this nitrogen dioxide which is cool and which spray with water to get nitric acid formed. So that means, what is that meaning of that equation? Here this nitrogen dioxide, I am writing here, nitrogen dioxide is react with water. I am writing for this side, nitrogen dioxide react with water to get what happen, HNO3 plus NO. So this nitric acid is formed 61%. Nitric acid is formed 61%. So this nitrogen, see again, 3 moles of okay. Now I am writing for this side. So nitrogen dioxide, this nitrogen dioxide spray with water to get what happen, nitric acid is formed. This nitric acid contain 61% HNO3. This nitric acid contain 61% HNO3. This HNO3 is recycled, the other nitrogen monoxide. That means this nitric acid is recycled and pumped out. So this is how to prepare this nitric acid. So this is nitric acid. So this nitric acid contain 61% HNO3, and thus nitric acid is dilute nitric acid is obtained by distillations. What happen? Concentrated distillations. It is concentrated and distillations. Distillation to get 68% HNO3 is formed. To get 68% HNO3. That 68% HNO3, the concentration is improved by 61 to 68. The concentration is improved by 98% HNO3. 98% HNO3. Concentration is improved by 98% HNO3 by dehydration and dehydration of sulfuric acid. Dehydration of concentrated sulfuric acid. Dehydration of concentrated sulfuric acid. This is Ostwald process. NaNO3 H2SO4 to get HNO3. This nitric acid which can be prepared from 2 processes, that is one Ostwald process and second one is Birkeland process. What is the Ostwald process? 4:5 ratio ammonia mixed with oxygen in the presence of platinum gas to get nitrogen monoxide. So this nitrogen monoxide is boiled with oxygen to get nitrogen dioxide. It is formed in the oxidation chamber. That nitrogen dioxide is sprayed with water to get HNO3. This HNO3 contains 61%. This HNO3 is concentrated in distillation to get 68%, and it is 98% is formed by dehydration of concentrated sulfuric acid. The next process is Birkeland-Eyde process. Next process is Birkeland-Eyde process. Birkeland-Eyde process. So what is the meaning of this Birkeland-Eyde process? Here first this N2 plus O2 used raised to 2NO. This HNO3 is a yellow color compound, it is a yellow color compound, and here iodine is converted into that means iodine is converted into iodide, and sulfur is converted into sulfuric acid H2SO4. At the same time phosphorus P4 phosphorus is converted into phosphoric acid, that formula H3PO4. Carbon is converted into carbon dioxide. So what is the meaning of that? We discuss one by one. So here iodine is converted into iodic acid. Means first I2. I will give a good technique for this one. Iodine is belongs to 7th group element. That 7th group element means NH2NP5. So what happened here, outermost 5, that's why 10 moles of HNO3. Iodine is converted into iodide. That iodide formula is 2HiO3. Two moles of HiO3. Other are common compound is, that is 10CO2. So other are common compound is like this. So which means what happened? So other are common compound is 10CNO2 plus here already 2 hydrogen, a 10, remaining 4 hydrogen less. That's why a 2, then next one is H2O. Here already 2 here. That's why here how many take 2 means take 4 H2O. So iodine is converted into iodic acid. Then sulfur belongs to 6th group element. 6 into here S6. Sulfur contain this sulfur contain S8 molecule, octate S8. It contains 6th group. 6 into 8, 48 HNO3. 48 moles of HNO3. Sulfur is contained sulfuric acid. That sulfuric acid formula is H2SO4. Sulfuric acid. Now that's why here 8 moles plus and 10 NO2. That means 48 NO2. That means sulfur is converted into sulfur dioxide. This is 8 H2SO4. 8 H2SO4 plus 48 NO2. 48 NO2 now plus H2O. Here how many hydrogen is there? 48. Here how many? 16. Now 16 minus 48 minus 16. 48 minus 16 2, here 32. That's why here take 16 moles. That's why you take 16 moles. Next one phosphorus P4 that react with how many? This phosphorus is belongs to 5th group element. That 5th group element is nothing but 20 HNO3. To get phosphorus is converted to phosphoric acid. That formula H3PO4. Here take 4 moles plus 20 NO2 plus here how many hydrogen is there? 20. Here 20, now here how much? 12 minus 12 equal to what happen? 8 nothing but 4 2 H2O. 8 nothing but remaining 8 is there, H2O. So that's why take 4 moles. At the same time next one carbon to carbon dioxide. So this carbon to carbon dioxide nothing but see, this carbon belongs to 4th group element, that is 4 HNO3. To get what happen? Carbon dioxide plus 4NO2 plus H2O. How many hydrogen is there here? 4. That's why here take 2 moles. This is iodine to iodic acid, sulfur to sulfuric acid, phosphorus to phosphoric acid, carbon to carbon dioxide, carbon to carbon dioxide. So, that means this is chemical properties of this one. One more chemical property is there, that is what happen when this react with metals. This react with what happen? Metals. What is the metals? Metal means copper, and the best example of metal is copper and zinc. Copper and zinc. So, now here copper that react to metals, here 3 moles of copper that react to HNO3, 3 moles of copper that react to HNO3 is nothing but 8 HNO3. To get common thing is formed, that is CuNO3 taken twice, So, here 3 moles, CuNO3 taken twice plus NO and H2O plus 2NO plus H2O. So, how many moles of H2O? This is 4 moles of H2O. Next, this is copper. Next one, copper react to again HNO3, no moles of HNO3. That means here no moles of copper that react to again HNO3, So, this copper react to HNO3, that means now take 4 moles to get what happen? CuNO3 taken twice, plus NO2 is formed, plus NO2, that means 2NO2 plus 2H2O. Now, after that, next zinc react to HNO3. Now, zinc react to HNO3, 4 moles of zinc that react to 10 HNO3, 10 moles of HNO3 to get zinc nitrate, ZnNO3 taken twice, Now, that is why here 4 moles. What we observed here, copper is there to get nitrogen monoxide, and no moles of copper to get nitrogen dioxide. If zinc is there to get what happen? N2O plus 5H2O, N2O plus 5H2O. Now, here how many nitrogen is there? Here 10 nitrogen, here what happened? 2, here 2 4, that is remaining 3. So, here 2 already there, 2 nothing but how many less is there? That is why take 4 N2O. So, this is this is no needed for this one, now already 4, right. Next one, zinc react to again HNO3, to get what happen? ZnNO3 taken twice, other byproduct are 2NO2 plus 2H2O, 2NO2 plus 2H2O. So, what we observed in this one, when copper to get NO, here no moles of copper to get 2NO2, zinc to get, if zinc is there, N2O, and no moles of zinc is there to get what happened? 2NO2. This is what is that compound? React with metal. This is completely nitric acid. What is the nitric acid? This nitric acid formula is HNO3. Nitric acid which can be prepared, how to prepare this one? Sodium nitrate that react to sulfuric acid to get nitric acid is formed. This nitric acid which can be prepared from 2 process, that is one Ostwald process and Birkeland-Eyde process. What is Ostwald process? When 4:5 ratio, ammonium mixed with oxygen in the presence of platinum gas to get nitrogen monoxide. This nitrogen monoxide is boiled with oxygen to get nitrogen dioxide. This nitrogen dioxide spray with water to get nitric acid is formed. This nitric acid is formed, thus formed nitric acid is recycled. That's formed nitric acid is recycled. This nitric acid is concentrated, and nitric acid to get what happen? 68%. That 68% nitric acid to convert it to 98, that is dehydration of sulfuric acid. So, that is Birkeland Ostwald process. What is Birkeland-Eyde process? This Birkeland-Eyde process, iodine is converted to iodic acid, sulfur is converted to sulfuric acid, phosphorus is converted to phosphoric acid, carbon is converted to carbon dioxide. React to metal. Copper react with HNO3 to get nitrogen monoxide, copper react with HNO3 to get nitrogen dioxide, but this is one is dilute condition, another one is concentrated condition. One is dilute condition, another one is concentrated condition. When dilute condition, nitrogen monoxide, concentrated condition, nitrogen dioxide. Dilute condition, nitrogen dioxide, nitrogen N2O, concentrated condition NO2. This is what happened, nitric acid. After this nitric acid, general properties of this fifth group elements. What is the general property? So, in these general properties, then first one, atomic radius. What is atomic radius? Atomic radius. The next one, aromaticity. The next one, physical state. So, catenation. Now we discuss. So, general properties. These general properties are basically following general properties there. So, that is, now remaining two topic is there, general properties and phosphine. So, what is the meaning of these general properties? Next one is general properties. General properties. So, these general properties are basically a few general properties there. Then first two general properties, atomic radius. First two general properties, atomic radius. Atomic radii. So, what is atomic radii? From top to bottom, this is nitrogen, phosphorus, arsenic, antimony, bismuth. Nitrogen, phosphorus, arsenic, antimony, bismuth. From top to bottom, atomic number are increases. From top to bottom, so this is 5, this is nitrogen 5 means, so from top to bottom, atomic number are increases. From top to bottom, atomic number are increases. Nitrogen atomic number is 7, so phosphorus, to be continued, from top to bottom, atomic number are increases. From top to bottom, atomic number, from top to bottom, atomic number increases. From top to bottom, atomic number increases. Atomic weight also increases from top to bottom. Atomic weight also increases from top to bottom. That's why that means the differentiating electrons enters into next higher energy cell, suggesting it has less predominant beyond of phosphorus. This is due to screening effect by inner d orbital. This is due to screening effect by inner d orbital. So, what is from atomic radius from top to bottom, atomic number are increases, automatically atomic weight also increases from top to bottom. That means the differentiating electrons enters into next higher energy cell, suggesting it has less predominant beyond of phosphorus. This is due to screening effect by inner d orbital. So, what happened? Next one, physical state. Second one is physical state. Physical state. What is the physical state? Here, nitrogen, phosphorus, arsenic, antimony, bismuth. In this one, nitrogen is a gas while other elements are solids. Nitrogen, phosphorus, arsenic, antimony, bismuth. Nitrogen is the gas. While other elements are solid. At room temperature. While other elements are solid at room temperature. This is physical states. After that physical state, the next one is, what is aromaticity? What is the aromaticity? After this physical state, next one is aromaticity. Third one is aromaticity. So, what is the aromaticity? Here, nitrogen. So, what is the nitrogen? Nitrogen atomic number is 7. Its electronic configuration what happened? 1s2, 2s2, 2p3. That's why what is here P. 1, 2, 3. This is 2px. This is 2py. This is 2pz. This is 2pz. So this is that means nitrogen content triple bond is formed. Nitrogen content triple bond. That's why 1 sigma, other 2 are pi, 2 pi. 1 sigma, 2 pi. So how to form? This is pz, this is py, this is px, this is pz. So there are 2 nitrogens, that is 1, this is 1 nitrogen, this is pz, py, px, another nitrogen, py, pz, px. These 2 overlap to get like this bond is formed. So this is sigma, other are pi, that's why nitrogen contain triple bond. Nitrogen contain triple bond. In this triple bond, one is sigma, other 2 are pi, Sigma electrons is formed by n on n overlap, pi electron is formed by side on side overlap. That's why nitrogen contain triple bond is formed. But other elements are contained tetraatomic. That means P4, tetraatomic. So these P4 are 2 type, that is one white phosphorus and red phosphorus. These P4 are 2 type, white phosphorus and red phosphorus. Both the formulas are same. White phosphorus is just tetrahedral in structure. Red phosphorus, red phosphorus is linear chain structure, linear chain in structure. So here bond order is 1. So simply this is what happened, white phosphorus. So this is 1, 2, 3, 4. So this is phosphorus. That's why P4. So this is 1, 2, 3, 4, 5, 6. 6 covalent bonds are formed. 6 covalent bonds. So this is white phosphorus. Red phosphorus is linkage of this one. So this is aromaticity. Next one, allotropy. Catenation. What is the catenation? After this aromaticity, the next one is catenation. So this fifth group element catenation is fifth group elements are formed catenation. That means the fifth group elements are formed catenations. The first 3 elements, nothing but what is nitrogen, phosphorus, arsenic. The first 3 elements are formed catenation. So this catenation is less than 4th group elements and 6th group elements. So that means 4th group elements are for catenation is very high. 4th group elements catenations are formed very high. 6th group elements also are formed catenation very high compared to this. That's why the catenation is 4th and 6th is very high than 5th group elements. In the 5th group element, nitrogen, the first 3 elements are formed catenation. The first 3 elements means nitrogen, phosphorus, arsenic is formed catenations. So now in this catenation, due to what happened, so from phosphorus to antimony catenation power is decrease. From phosphorus to antimony, nitrogen, phosphorus, arsenic, antimony. From phosphorus to antimony, catenation power is decrease. Catenation power is decrease. So this is what happened. Atomic radius from top to bottom, atomic number are increases, atomic weight also increases. That means the differentiating electrons enters into next to higher energy cell, suggesting it has less predominant bond of phosphorus. This is due to screening effect by inner d orbital. Physical state, nitrogen is a gas while other elements are solid at room temperature. Aromaticity, nitrogen contain triple bond. So in the triple bond, one is sigma, other two are pi. Sigma electrons are formed by end and end overlap. Pi electrons, pi bonds is formed by side and side overlap. And then phosphorus. Phosphorus is other elements are from tetraatomic. Other elements are from tetraatomic. Other elements are from tetraatomic. That is, phosphorus contain two types. That is P4, white phosphorus and red phosphorus. White phosphorus is just tetrahedral structure. Red phosphorus is linear tetrahedral. Linear tetrahedral. Its bond order is 1. Its bond order is 1. In the phosphorus, it contains each phosphorus bounded to 3 covalent bonds. Each phosphorus bounded to 3 covalent bond, but in each phosphorus is total 6 coordinate bond. It's total 6 covalent bond. 1, 2, 3, 4, 5, 6. Its bond order is 1. Catenation. The first 3 elements are from catenation. The fifth group elements, the first 3 elements are from catenation properties. Nitrogen, phosphorus, arsenic from catenation compound, then compared to 4th and 6th group elements. That means 4th group elements are from more catenation power. 6th group elements also from more catenation power compared. That's why that for catenation power is top to bottom or decreases from phosphorus to nitrogen, phosphorus, arsenic, antimony. Antimony catenation power is decreases. That after that catenation topic, general properties. Next one is a last small topic, that is phosphine. Next topic is goes to phosphine. So how to prepare, this is the last topic in this chapter, how to prepare this phosphine. Phosphine which can be prepared from what happened, calcium Ca3P2, calcium phosphide. Phosphine which can be prepared from calcium phosphide Ca3P2 that react with water and HCl. That react with water and HCl to get phosphine is formed. So this is the last topic in this chapter, Ca3P2 that react to water and HCl to get phosphine. That phosphine formula is PH3. Phosphine formula is PH3. So next last topic in this chapter is phosphine. 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 How to prepare this phosphine? Phosphine formula is PH3. Phosphine formula is PH3. How to prepare this phosphine? Ca3P2, that nothing but calcium phosphide, Ca3P2. Ca3P2 that react with water, 6 moles of H2O to get phosphine. Phosphine means PH3. Here how many phosphorus is there? 2 plus CaOH taken twice. CaOH taken twice. So that's why here take 3 moles. 3 moles. So I am writing again here Ca3P2 so that's why 3 moles of CaOH twice is formed. 3 moles of CaOH taken twice. At the same time Ca3P2 that react to 6 moles of HCl to get phosphine. What is the formula of phosphine? PH3. Here take 2 moles. But here calcium is there, to get what happened? 3 moles of CaCl, 3 moles of CaCl2. CaCl2 is formed. This is phosphine. Phosphine which can be prepared from this phosphine, calcium phosphide. Calcium phosphide is react to H2O and HCl to get phosphine is formed. After that this phosphine react to base, phosphine. So phosphorus, that is white phosphorus P4 that react to alkalis, 3 moles of NaOH and undergoes hydrolysis to get phosphine. So what is the formula of phosphine? PH4 plus a salt compound is formed. That salt compound formula is NaH2PO2. 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 Now here that's why in this phosphine, so that's why here take Here take 3 moles of NaH2PO2. So calcium phosphate is undergoes hydrolysis and HCl to get phosphine. Phosphorus react to NaOH and water to get phosphine. To get what happened? Phosphine. The next one, chemical properties. In these chemical properties, then first one, react with HI. First, react with HI. HI. So PH3 react to HI. HI to get PH4I. PH4I. The next one, react to this PH4I, react to KOH. PH4I react to KOH to get phosphine is formed. What is the formula of phosphine? PH3 plus Ki plus H2O. That means this phosphine which can be prepared also, phosphine react to HI to get PH4I. This phosphonium iodide react to KOH to get phosphine. To get what happened? Phosphine. The next after that react to HBr, potassium bromide, HBr, hydrogen bromide. So phosphine formula is PH3, that react to HBr to get what is the compound? Right. So this last one, HBr, phosphine, that react with to HBr to get what happen? PH4Br. This is phosphine. So this phosphine, phosphine is used in whole maize. So that means whole maize. This phosphine is used in whole maize signals and also smoke screens. Whole maize signals and smoke screens. So this is phosphine. Last topic is anomalous behavior of ammonia. Anomalous behavior of ammonia. This is the last topic in this one. What is the anomalous behavior of ammonia? Last a small topic, that is anomalous behavior of ammonia. Anomalous behavior of ammonia. Anomalous behavior of nitrogen. Anomalous behavior of nitrogen. So what is the anomalous behavior of nitrogen? Now in this one, nitrogen is a gas while as elements are solid. Nitrogen, this first point, nitrogen is a gas. Nitrogen is a gas while other elements are solids. Nitrogen is a gas while other elements are solid at room temperature. Next one, nitrogen is a diatomic molecule. This nitrogen is a diatomic. While other elements are tetraatomic. Nitrogen is a diatomic while other elements are tetraatomic. So here nitrogen is formed trihalides. While other elements are formed trihalides as well as pentahalides. As well as pentahalides. Okay. Next point is nitrogen does not form, right, okay. Nitrogen is formed many oxide. Nitrogen is formed many oxides while other elements are formed trioxide and pentoxide. Next point is nitrogen is oxidation state is -3. Nitrogen is predominantly -3 oxidation state while other are +3 and +5 oxidation state. Nitrogen is predominantly -3 oxidation state while other are predominantly plus 3 and plus 5 oxidation state. Next one is what happened? Nitrogen is a abnormal behavior of what is abnormal behavior of nitrogen, abnormal behavior of nitrogen. So, this is nitrogen is a small size, nitrogen is a small size, nitrogen is a small size. Options of d orbital, options of d orbital, options of d orbital, and high electronegativity, high electronegativity. So, nitrogen is a small size, options of d orbital, high electronegativity, and it contain multiple bond, that means it contain multiple bonds. Nitrogen contain multiple bonds, nitrogen contain multiple bond, and what happen? It contain having only 2 electron in the penultimate cell, 2 electron in the penultimate cell, in the penultimate cell, 2 electron in the penultimate cell. So, what is the meaning of this penultimate cell? So, penultimate cell means, for example, this is 1, 2, 3. So, this is K cell L M. So, this is valency cell, this is valency cell, this is penultimate cell, this is anti-penultimate cell. So, the starting ending is nothing but valency cell, ending electrons are called valency cell, before are called penultimate, then after anti-penultimate, this is anti-penultimate cell. So, this is completely 5th group element, this is complete 5th group element. So, next we discuss based on what I discuss on the today topic, next class bits on this topic. Okay. Now, to be continue on next class. Okay. Thank you very much.